Hello everyone, my name is Vaishnav Kurade and today we are here to present our ISC of Digital Signal Processing MATLAB code for Butterworth Low Pass Filter under the guidance of R.T. Patil sir. So let us see what is meant by Butterworth Low Pass Filter. A Butterworth Low Pass Filter is a type of electronic filter designed to allow signals with a frequency lower than a certain cutoff frequency to pass through while attenuating signals with frequencies higher than the cutoff frequency. It belongs to the family of infinite impulse response filters. It was first described in 1930 by the British engineer and physicist Stephen Butterworth in his paper entitled On the Theory of Filter Amplifiers. Now let us see how does Butterworth low pass filter work. The working of a Butterworth low pass filter involves a process where it allows signals with frequency below a certain cutoff frequency to pass through relative unchanged while attenuating signals with a frequency above the cutoff. So first we have to select frequency selection. You decide on a specific frequency point called the cutoff frequency. This is the point at which the filter starts to attenuate or reduce the strength of the signal. Then there is a transfer function. The Butterworth low pass filter uses a mathematical equation known as a transfer function to describe how it treats different frequencies. The transfer function for Butterworth low pass filter designed to have a smooth and flat response in the passband. Then there is a filter order. You choose the filter order which determines how quickly the filter starts reducing the strength of signal beyond the cutoff frequency. A higher filter order means a steeper roll-off. Then there is a circuit design. Engineers used to choose cutoff frequency and filter order to design a circuit that implements the Butterworth filter. The circuit may involve capacitor, resistor, and operational amplifier depending upon the specific requirement. Next, there is a signal processing. When a signal passes through the Butterworth low pass filter, the filter circuit processes the signal. If the signal has a frequency below the cutoff, it passes through the filter with minimal attenuation. If the signal has a frequency above the cutoff, the filter reduces its strength based on the transfer function and filter order. Then there is a roll-off. The roll-off refers to how quickly the filter reduces the strength of the signal beyond the cutoff frequency. For a Butterworth filter, the roll-off is gradually and predictable, providing a smooth transition between the passband and stop band. Now, let us see a MATLAB code.
Hello everyone, I am Sanika Sawant and let's break down the MATLAB code for Butterworth low pass filter. So these first three lines are there for clearing the command window, clearing all variables and closing all figures, and these are there to ensure a clean workspace. Then we'll see how to generate a noisy signal. So here noisy signal is generated with these following commands. It has sampling frequency of 1000 Hz, which is denoted by a variable called fs. Then a time vector t is ranging from 0 to 1 second with the step size of 1 upon fs, and an original signal which is a sine wave with a frequency of 10 Hz is generated over here. Gaussian noise is added to the original signal and the resulting noisy signal is obtained by adding the original signal to the noise. Then we'll see how to display the original and noisy signal figures. So for this we'll use subplot and plot commands, and this part will help us to plot the noisy and original signals. So first we'll plot original signal in third row, first column and first position. By using plot command, we'll plot the original signal. Then we'll give labels. Then we'll plot noisy signal at third row, first column and second position. After plotting noisy and original signal, we'll apply the Butterworth filter to this noisy signal. And for that, we'll use fit function. By using this function, we'll apply the noisy signal to the Butterworth filter to obtain the original signal. By using this command, we'll get filtered signal, and to display that filtered signal, we'll again use subplot and plot command, and we'll plot this filtered signal at third row, first column and third position. We'll give label to it. And this is how we can get filtered signal by using Butterworth low pass filter. Now see how the code is implemented in MATLAB. This is the code which I have explained earlier, and here is the output of this code. Let's see the output of this code. So as you can see, first is the original signal which we have plotted, then second is the Gaussian noisy signal, and when we apply Butterworth filter to this noisy signal, we'll get the original filtered signal which is more than 90% similar to the original signal. So this is the working of Butterworth low pass filter. Now let's see applications of Butterworth low pass filter in DSP.
Butterworth filter are commonly used in a digital signal processing of various applications due to their desirable characteristics. So first of all, signal smoothing. Butterworth low-pass filter are often used for signal smoothing or noise reduction by attenuating high-frequency noise or rapid changes in a signal. Data processing. In many applications, especially in biomedical signal processing and communication system, data pre-processing is crucial. In image processing, Butterworth low-pass filter can be employed for tasks such as blurring or reducing high-frequency details. This is useful in application like image smoothing. Next, audio processing. Butterworth filter are commonly used in audio processing applications to remove high-frequency noise, distortion, or unwanted components. The next is in sensor application, where measurements may be affected by noise or high-frequency interference. Butterworth filter can be applied to filter out unwanted components and provide more accurate representation of measured signal. So now it is essential to consider the filter order and cutoff frequency based on specific requirement of the application. These are some applications. Thank you so much.